Hey, hello guys, this is Vargas Mongo 3435. I guess many people did like my video about how to create a 3D PCB using the Gerber files so to be studied or to analyze any circuit that you are making with the Spring Layout 6. Basically my channel is more how you say concentrated into Spring Layout 6, so you can create your own PCBs for any other projects. Can be audio amplifiers, equalizers, maybe some sort of a control for the those whatever. I don't know. There's many ideas for PCBs for you to make your own circuit. Right now I'm going to make another one, so I guess many people like this video. So I got 94 views. It's not much, but at least there is not many people that like this stuff. So all right, I'm gonna make another one more time. I'm going to show you using one larger circuit that I have here. This is a simple unregulated class AB power supply that I was designing last year. So this year I decided to tweak it a little bit more, so just to fix some stuff. I think I look at here, I think I moved something here. I don't think this is correct. Let me see. Let me see. That's kind of funny. Let me see. There you go. I gotta make sure everything is correct. All right, so I guess I moved that layer with I did not notice. It's okay. I think it's fine. Yeah, it is. It's fine. All right, to explain you better, this unregulated power supply for Class AB audio amplifier, I decided to make it place many options so I can just, one example, if I am going to use terminal connectors. I'm going to show you the components little bit by little bit. What I do, okay, let me go to DigiKey. Okay, I got DigiKey right here. Sorry about that, I save it. All right, I got DigiKey. That's my, I use this website as a reference so I can search for components. Also I use Mouser. Mouser is pretty good too. All right, I'm going to show you what I mean about options. So here, as you can see, I can either use a fast-on connector or either I can use a terminal connector. I'm going to show you what it is. So the only thing I gotta do is double click into the part number, place it here on DigiKey to search for that particular component. So this is just a simple screw type terminal connector. So I think this is a safer way to do it because you can use a O-ring or ring terminal. Sorry about that, ring terminal. So you can secure that wire really safely into that type of connector. And I think they have the PDF file so you can see what I did. I just, oh, this look a lot better. This at the beginning I made it like this with all this illustration on the screws, but it's not really necessary. The most important part of the terminal connector is just to use the bottom. One example, this here, the measurements. All right, we have here 3.8 millimeters from the plastic from here to this area of the holes. It says this pitch distance between the holes is 6.35 millimeters. We have 14 millimeters of the wiring, the size of this terminal plastic. And what else? What I check here? All right, so we had 6.35 millimeters. So that's what I did. I just create. Okay, as you can see, we got 6.35 millimeters. But also a fast-on connector can be used here instead of that. In one example, if you don't have, you don't want to purchase that component, you can just purchase a bunch of fast-on connectors. I think, let me see if I have the part number. I forgot. I gotta show you this slowly. I kind of like to make these videos so you guys you can use this reference for your ideas and projects and stuff like that. Okay, no, it's not that one. I need a male type terminal connector. So it's basically this one here. That's the male connector. I gotta check for the measurements. So I know this is to buy a large quantity of those. Okay, there you go, 11 cents, and you can buy maybe 30 or 40 of those. Here there is information of the PCB measurements. As you can see, this is 5.08 millimeters, and the thickness of these devices is about 1. Let me see, 1.31. Yeah, 1.31 should be fine. So this is the legend, the PCB board hole pattern. So you can export that information into your spring layout 6. So 5.08 millimeters. So on this PCB, they all will have a, there you go, I'm going to measure here, 5.08 millimeters. So this is ready to use a fasten connector. So we have two options here. That's why it took me a long time to put it together. So I wanted to have the most options I can get. So here you can either use this type of fasten connector, or you can use a screw type for the ground, the center tap of the toroidal transformer. Here I decided yesterday, I was thinking maybe it should be a good idea to have a special type of terminal, so I can screw a wire here into the center of the power supply, the center tap. Mostly for audio applications should be a good idea. So this is another part component. I'm going to show you this one, and there is music outside. So this is another type of component. So I can screw the ring terminal there and secure that ground connection there. So that will make it a really strong connection. So, and here it has all the information, like all the other components. So here is the legend. As you can see, that's what I did. We have from pad to pad, from hole to hole. That sounds a little bit dirty. Okay, 5.0 millimeters, 5.0 millimeters, and 7.0 millimeters. So this is easy to make. It's not that really difficult, guys. It's really easy. I'm going to show you how to do it, so you don't get confused. All right, I'm going to do it. I'm going to make that one. Sorry, it's too early, and I have an early breakfast. Yes, indeed. All right, let's go on to make this one here. I'm going to create this one here. It's not that really difficult. I'm going to explain you why I have these extra 2 pads, because these you can actually use the fasten connector and place solder that here, so you will have most of the options available for this connection. All right, I'm going to create this fasten this particular component to secure the wire. So let's do it right now. We're going to extra footprint wizard. We are going to create the same component, dual row. I think the information says it needs only 3. Here on the top, where you see the letter D, you will change this to 5. I think it's 5. Yeah, it is 5 millimeters. There you go. The thickness of the holes, let me see, 1.93 millimeters diameter hole. So let's go with 2 millimeters. Make it, yeah, this should make 2. So it's good that I read this, man. All right, 7 millimeters. Sorry about that. 7 millimeters. I'm glad that I read that. Something escaped to me. All right. So let's go square that out to 2 millimeters. I don't think it's necessary to be that accurate. But 4.50 should be fine. But you can see I just made it. But now that I look at the information, at the this thing escaped to my eye. So 1.93 millimeter diameter hole. So yeah, that information escaped. Actually, yeah, here. Sorry about that, guys. It says 1.52 millimeters thickness. 1.52 millimeters. I'm looking at this, the thickness of the leads from that component. So I think mounting details. It says minimum 1.93, so I should go with 1.95 probably. No, 1.95. I think this is the best choice. So let's change this for 1.95. Let's go with 2 millimeters. It's okay. 2 millimeters is fine. There you go. So we're gonna be sure that we're not gonna have any problem with this with that particular component. So now we know that it's 2 millimeters. Now the one that I made, this one here, I'm just gonna place it on top of the one that I made a long time ago. So they match. As you can see, they actually match using that technique. All right, as you can see that. So that is pretty simple to do. Here on this component, let me see the terminal. Let me see. I'm about to explain you something, but I think it's not necessary. It's not that really necessary. It's fine. It's fine, guys. Don't get confused. All right. So I decided on in this PCB to add the diodes and the heat sink to cool down those devices. I don't think they're gonna get that hot because I'm not gonna push the other amplifier that I have. I'm not gonna push them too hard, because I'm probably just gonna listen to music, soft music. I'm not gonna use it for, you know, high power devices, audio amplifiers. So here's the diode. I'm going to show you what component it is. So that's what I do. I just write down the component and I place it into the PCB, so I don't have to search for the list of components. So I'm going to show you that particular component, because this is the diode. I don't think this is the actual image of the diode, so you can see right now. Let me see, I need to read the information. Okay, this one is 20 amps, 400 volt. That should be just enough for my audio application, so it should be just fine. This is a ultra fast diode with a low forward voltage drop. This device is intended for use as freewheeling and clamping diodes in variety of switching power supplies and other power switching applications. It is specially suited for use in switching power supplies and industrial application. Holy shit, industrial application. Alright, so here we got the information. And you can see here, we got the information. This is the first number one is a cathode, and the number two is an anode. So that's what I use for this special application for this power supply. You can see it's a illustration of the diode. The cathode is a square and the anode is the circle, so that's why I place it like that. So I also have the heat sink part number. I think the one that I choose is way too big. Probably I'm going to choose a different size, not that high. I think the high is too big. So this one I think is too big for that application. So you can see it will be attached to the PCB, but I can solder that particular component to secure it. So the diode is going to be secure. All right, let me see. I think this is the legend, the mounting of the. All right, there you go. All right, let me see. I need to read the. Okay, this information here. All right, there you go. So we have the heat sink here. We have the many sizes, you know, for different type of semiconductor, I guess. That's why I got many holes here. I got 3 holes. The bottom information is really important. As you can see, the pitch distance between these solderable pins or leads that secure the heat sink is 25.40 millimeters. And the diameter of the hole, it says 2.37. I think I choose 2.40 if I can remember. Let me see. So we got the holes here. I gotta measure that so you guys can see. So we have here exactly 25.4 millimeters, and the diameter of the hole is 2.40. And I'm sorry about that, guys. I'm moving the microphone. I'm thinking that I should make this hole. No, I think it's fine. It says 2.37 and I choose 2.40. I think it should be fine. Maybe it's gonna be a little bit tight after I place it into the PCB. Yeah, I did not make a drawing, but I don't think it's necessary. You're not gonna see all the artwork. I I was about to make this illustration for the. Actually, I can do it. I mean, I can do it to make it nice, but I don't think it's needed because the heat sink is gonna cover all that up, so I don't think it's necessary. So that's why I did not make that that drawing there. So I just make it simple. You can see I just make this illustration. So what is another information? Hey, there's a more 820. So this is the data that I choose for the application. All right, cool. It's cool now. I was thinking something that probably you don't notice that, guys. There is a little problem, but it's not a big deal. But the problem here is that I have to install first. Actually, it's not that bad. I can install both all the diodes on the heatsink, and later I can install the capacitors. So yes, it's fine. It's not a big deal. I don't think those diodes they're gonna blow out that fast. I'm not gonna place a piece of wire in the output, so it makes no sense. So it should be fine. All right, now we have the capacitor C7, C8, and we have C9 and C10. Those are the snubber capacitors. I think that the value is 0.01. I think it's 0.01 picofarad. I think it's picofarad. So I gotta explain you that later because it's maybe too much information to snubber capacitor. All right, we have the bleeder resistor. I was making a simulation yesterday, and the circuit works pretty good. Yeah, it's just a simple circuit. It's not that really complicated. There's no regulation here. It's just unregulated power supply, so it's no big deal. So the bleeder resistor, I think I can choose a different value, maybe 16K. So after I turn off the amplifier, those resistors they're gonna be in charge of how you say, they bleed out the capacitor to make sure there is no voltage present into those devices, so they will drain the voltages from the capacitor after the amplifier is turned off, so they will not keep the charge. So that's the reason why I have those devices there, those resistors. They need to be 3 watts. I don't think they're gonna consume that much power. I do have the simulation here, guys. Let me see if I can find it. All right, I got a lot of stuff on my. Yesterday I was cleaning my computer. I had to delete some stuff that I have. I got a lot of stuff. So okay, this is the circuit of the power supply. Right now we have basically the same. This is the snubber capacitors. The snubber. I think it's to avoid some kind of a noise and stuff like that from the switching or the other places in the house. So we got 22,000 microfarad. It's 44,000 microfarad. That's a lot. We got the R, the bleeder resistors, 16K. Do not mind about the part number R1. So don't mind about that. I gotta fix that. We got the LEDs just to show the power supply is working correctly. We have the outputs here to measure the voltages. I'm thinking to order later a toroidal transformer, a 600 volt toroidal transformer. So I'm going to show you now. We got 55.8 volts DC. We got positive 55.8 and negative 55.8. Exactly, they are the same number. And this is the oscilloscope showing the DC output. No ripple so far. Well, because it's 22K. Maybe there is another. I was thinking to add the CRC filtering. I was thinking to do that. I'm not sure if I want to do that, because here on the PCB I do have space to place a resistor but I think it might need more than 3 resistors to able to do that. So to accomplish that, I don't think it's necessary, but I was thinking to do that. I'm not sure. So this is the idea that I have. I was thinking to place a R. It will be CRC filtering. It should look like this, but I think it's not really that necessary. I was thinking not to do that. because I will need more than 3 resistors in parallel, so that will make the PCB a bit larger, so I really don't want to do that. So no, it's fine. It's fine. I'm not gonna do that. All right, cool. Oh, I forgot to show the. All right, let me close this. I'm glad that I have the, how you call the soft start circuit for the toroidal transformer, and maybe later I will order a few PCBs of that type of. Oh, let me see. Okay, cool. Just gotta make sure it's not that much. All right, let me see. 186.50. There you go. Cool. Now it's correct. So that's the idea of the unregulated power supply that I have for all the audio amplifier that I have. So I'm thinking to get me the 40 volts. So that's why I changed it. As you can see, I made a simulation like 2 windings, 2 40 volts windings, and I placed those together. So here is basically this one here. It creates the center tap of the power transformer. I think 40 volts should be just fine because it's giving me about 55.8. Maybe in real time, it might be reaching this almost 60 volt DC, because the honey badger that I built the other day. So I took some pictures today with. Sorry about that. Yesterday, forgot. Took some pictures. This is the honey badger. So also I had to do something else. I need to change this the orientation of this RCA input. I had to change that to 90 degree because I have a little problem here. As you can see, unless I can find a 90 degree RCA cable, so I don't have to worry about that. So I probably, let me check. Sorry about that, guys. Let me go to Amazon to see if they have it, because I purchased stuff in Amazon. Let me see. This is Amazon. All right, let me see. So it should be 90 degree RCA cables. Let me see, they have it, just to make sure. Okay, that is a good solution. It's kind of expensive, but that will fix my problem that I have. But it's a little expensive, $10 for that. Oh, 5-pack. Okay, that's pretty good. So actually, I don't have to do any changes on the. Okay, say 2-pack is $7.99. Well, it's kind of expensive, a little expensive. All right, so I guess I don't have to worry about that. It should be just fine. All right, cool. Let me see. I always do this. Average customer review. Let me see. No, okay, I don't need 5 of those. Yeah, okay, this is crazy. It says 2-pack, $7.99. What the hell is going on here? $7.99, and you got 5 for $9.99. What the hell is this? Just for a few more dollars, you can. I don't need 5. Why should I need 5? Let me see this. Oh, I see what's going on. But that will work just fine for the honey badger. Yeah, I think so. It's pretty good. So it should not look like this anymore. So with that thing, yeah, cool. I don't have to make any changes to the PCB. All right, cool. Let's go back to the. I think I made this video way too long. All right, let's make the Gerbers. Let's go back and make the Gerbers. Export Gerber. C1, C2, S1. Outline is really important. C1, C2. Punch drill holes, include frame, board size, and then we change the name, not to make it too long. So power supply should be just fine, and we're gonna choose the folder power supply Gerbers. This is the one that I just made. All right, create the Gerber files. 6 files are created, and the last file is the drill data exalion. You don't have to change anything here. This is the same way I've been doing it for a long time. I already ordered a few PCBs and I don't have to change anything here. It's in inches, format 2.4. So now we're gonna change this name to drilling, so the Asian guys, they know what it is. Sorry about that, guys. That sounds so racist. Drillings. Okay, we got the file drillings. All right. So I'm gonna save this because I have made some changes. And now we're going to close this because I don't need it. Power supply. Say no, it's okay. 55 volts. All right. Got a lot of stuff on my computer. I just cleaned it up out yesterday. I saved the data that I have that I really don't need on my computer. So I delete some stuff, also games that I play video games too. So I had to delete games that I have not playing for a while. So okay, we got compose a new file. Let me make this bigger. Manual. Choose the desktop. Power supply Gerbers. Drilling. We got to insert all this file into this window. 1, 2, 3, 4, 5, and 6. It's going to be 6 files. If you are using Spring Layout 6, it's going to be for 2 layers. It's going to be 6 files. I forgot how many for the 1 layer. All right, I gotta make a video about that later. Okay, seal screen. You gotta identify that file, and then you will choose seal screen, and you will move that file up. This is going to be the first file. The second one, it says solder mask top. It's already correct, so we need to change that to solder mask. The other one is solder mask bottom. We're gonna change to bottom. This is outline, border outline, and then I type here 850. Let's go to change this to 850. Set equal spacing. There you go. Copper bottom. We need to move the solder mask bottom under the copper bottom. So we have the first file is seal screen. The second one is solder mask top. The third file is copper top. The other file is copper bottom, and then it will continue with the solder mask bottom and outline, and it's ready to generate that image. So as you can see, this is a complete a 3D view of the PCB that I designed. It's been like a year and a half, something like that probably. It's simple, but when you open the file and you look at it, you'll be like, man, I think I should add this option to this PCB, so if I don't have this part number, I can just use the fasten connector or terminal. You got the idea. You got the idea. All right. So, yeah, I forgot to explain you something here. There is no hole here because I forgot to change this. It should have a hole for the screw. I forgot. Sorry about that, guys. I forgot to change this to hole to create a hole because the seal screen is on top of this. I think it's not matter. I don't think it doesn't matter. All right, cool. All right. So now that I create a 3D image of the PCB, I can just save it, render the board, save as, and place it in. I'm gonna place it into my desktop, and then I'm gonna rename this to power supply multiple. Multiple means that I can choose many sizes of capacitor. That's why I designed it in this way. I'm going to show you right now. This is the part number. I'm going to show you the part number is this one here. Alright, this is a really large capacitor. As you can see, this is a big capacitor, so it's a 50mm diameter, and it's rated to 22 microfarad, 22,000, sorry about that, 80 volts. So it should be just fine for my applications. They are kind of expensive. It's like $14, $14.20, $14.19. Sorry about that. It's kind of expensive, but it's better than purchase maybe 8, 10 microfarad. They are kind of expensive. 10,000 microfarad capacitor. One example, if you're gonna purchase to get a larger number, you gotta purchase more. So one example, we have, let me show you the 10,000 microfarad. Okay, this is the most common capacitor for audio application that I have seen. So one sample, 80 volts. Let's go with normal voltage, 80 volts. Let me see. Okay, we had those. These are $10, $9, because these are 80. Well, that's not bad. It's not that bad. You see the cost of one single 10,000 microfarad is $10 something. You know, $10.46 or whatever. It's kind of expensive. You can see. That's why I decided to make it with this design, so I can choose many sizes of capacitors. So that's why I have multiple paths for multiple applications, so more than 3 or 4 models of capacitors. So right now I can choose a 35 millimeter diameter capacitor, a 40 millimeters, up to a 50 millimeter. That's the largest capacitor I can fit into this PCB. That's why I designed it this way. All right, guys, I think it should be fine. This video should end right now. I think you guys got the idea. I think I've repeated myself many times. All right, guys, have a good day. I hope you like this video. Please share this file. I'm sorry, this file. Sorry about that. Share this video. Give a like to this video and subscribe to my channel. You know, and have fun. All right, guys, have a good day.